to 13. Let's get started. The unknown resistance of the given Wheatstone bridge is R1 is equal to 5 ohm, R2 is equal to 20 ohm, R3 is equal to 10 ohm, and we have to find R4. We know that for a balanced Wheatstone bridge, it must fulfill the following relation, which is the ratio of R1 to R2 must be equal to R3 to a ratio of R3 to R4. As we are given with the values for R1, R2, R3, we can find the value of unknown R4 resistance. Just put in the values and cross multiplication, we can find the value of R4, which is equal to 40 ohm. So our correct option is option D, 40 ohm. Let's see question number 10. Heat generated by a 40 watt bulb in an hour is, well, just using the formula for heat, which is the product of power into time. As the value of power is given as 40 watt, time is 1 hour, which is equal to 3600. Just multiplying these two values, we get the answer is 1,44,000 joule. Question number 11. If the resistivity and cross-sectional area of a metallic wire remain constant, then on increasing its length, the resistance of the wire will, options are option A increase, option B decrease, option C become 0, option D remain constant. To answer this, we refer to the formula for resistance, as resistance is directly proportional to length of the wire and inversely proportional to the area. As resistivity and area of wire remain constant, then on increasing its length, the resistance of wire will also increase, as it have a direct relation. Let's see question number 12. When a shunt is connected parallel with a galvanometer, it is converted into and options are ammeter, option B is equal to voltmeter, option C ohm meter, option D photometer. When a shunt is connected parallel with a galvanometer, it is converted into an ammeter. Let's see the explanation. A shunt allows most of the current to bypass the galvanometer, enabling it to measure large currents without being damaged, effectively converted it into an ammeter. So our correct option is option A. Now see question number 13. If a charged particle of 2 coulomb moves with a velocity of 3 meters per second perpendicular to a magnetic field of 1 Tesla, then magnetic force acting on the particle will be, options are option A 3 Newton, option B 4 Newton, option C 5 Newton, option D 6 Newton. To see the answer, we can refer to the formula for the magnetic force on a particle in a magnetic field, which is equal to F is equal to Q charge into velocity into magnetic field into sine theta. As the velocity is moving, as the particle is moving perpendicular to a magnetic field, so our theta is equal to 90 and sine 90 is equal to 1. So we have the values. We have to put the value for charge, velocity and magnetic field only. By putting the values, we can get the answer as 6 Newton. So the correct option of MCQ 13 is option D, 6 Newton.